Constants.
Next topic is the constants, right? Okay. So types of constants.
Primary constants. Secondary.
Primary and secondary.
Primary and secondary. So what are the primary constants?
Resistor.
Resistor, capacitor, conductance.
Constant.
ILCG.
So these are the primary constants, and while coming to secondary constants,
Z out. Characteristic.
characteristic,
Impedance, propagation constant,
propagation constant,
Phase constant.
radiation and phase constant, and next
wavelength.
wavelength. Right? So these are the primary and secondary constants. So these will affect the transmission lines, right? So the parameters of these constants will affect the transmission line. How it will be affect, and the parameters. What are the parameters? So R means,
Resistor.
so it is a transmission line, right? So L, R and C, G, right? So it is a transmission line of 1 unit line, right? 1 unit length. Are the primary constant. So first one, what is R? R means resistance, right? So the resistance means here it is a loop resistance of 1 unit length. Series loop resistance of 1 unit length in the transmission line, that is called resistance here. Okay? Clear? It is a loop resistance of 1 unit length in the transmission line. That is a resistance. And next coming to L, inductance means, సేమ్ అదే వేలో చెప్పండి.
Loop inductance in 1 unit transmission line.
This is a series loop inductance
Inductance 1 unit.
of 1 unit length in the transmission line. Okay, so that is L. And next coming to C.
Parallel loop capacitance in a 1 unit.
So it is a
Madam, voice.
Okay. So C means it is a shunt capacitance between two wires in 1 unit length. Okay.
Okay, ma'am.
Hey, Eternal. Is this clear? Is the C means?
1 second, madam.
Hmm?
1 second.
Is a shunt capacitance between two wires in 1 unit length of transmission line. So here for L and R, these are the series components, right? So that's why you said series, either resistance or inductance. Okay? So C and G are parallel components, right? So that means shunt also means parallel. Okay? We can also call shunt, that means parallel. So it is a shunt capacitance between two wires in 1 unit length. That is a capacitance. And G means, I said conductance, right? Yes? G means conductance. So it is a parallel, that means shunt. It is a shunt conductance between two wires in 1 unit length. Okay? 4 definitions. R, L, C, G. Clear?
Yes,
Yes,
madam.
ma'am.
So R means series resistance. L means series inductance. C means shunt capacitance between two wires. G means shunt conductance between two wires. So all are considered for 1 unit length, right? 1 unit length in the transmission line. So these are the primary constants. So this one clear?
Yes, ma'am.
Okay. And next one is the secondary constants. Okay. So in that, what is the first one?
Characteristic impedance.
Characteristic impedance that will be represented with Z0. Characteristic impedance. So impedance means
Resistance.
resistance, right? So resistance definition.
Strict flow of
V by
It is the
I.
flow of the current.
In terms of V and I, V by I are equals to, right? Okay. That means Z net can also represented I as V by I. Okay. So in the transmission line, what is characteristic impedance? Okay. So if the transmission line is infinite, we are consider the infinite transmission line. Then the impedance measured at the input terminals of the transmission line. So it is a transmission line, right? So it is the input terminals, it is the output terminals. Then the impedance measured at the input terminals of the infinite transmission line, that is called characteristic impedance. It is the input terminals, right? అవునా?
Yes, ma'am.
సో మనం ఇక్కడ ఏదైతే ఇంపెడెన్స్ మెజర్ చేస్తున్నామో ఇక్కడ ఏదైతే ఇంపెడెన్స్ మెజర్ చేస్తున్నామో దట్ ఈస్ కాల్డ్ Z0 క్యారెక్టరిస్టిక్ ఇంపెడెన్స్. That's what I said. Okay, so the impedance measured at the input terminals of the infinite transmission line. So clear? Definition: characteristic impedance Z0. Okay na? నేను చెప్పినప్పుడు రాసుకోండి డెఫినేషన్స్, then you can easily remember. So Z not clear, right? Okay, so in terms of primary constants, how we can represent Z0? So it can be represented with R plus J omega L by G plus J omega C of square root. Okay, characteristic impedance in terms of primary constants, that is square root of R plus J omega L by G plus J omega C. So పైన ఏంటి సిరీస్ కాంపోనెంట్స్ అండ్ కింద ఏమున్నాయి మనకి షంట్ కాంపోనెంట్స్. ఓకేనా? So this one clear? What is Z0? And Z0 in simply we can represent it with V by I in terms of primary constants square root of R plus J omega L by G plus J omega C. Okay, so it will be considered at low frequencies. Okay, then what about high frequencies? What is Z0 at high frequencies? Can anyone say? చెప్తారు ఎవరైనా? What happens in this equation while we are considering the high frequencies? No one? నిన్న ఏం విన్నారమ్మా క్లాస్?
రూట్ క్యాన్సిల్.
రూట్ క్యాన్సిల్ అవుతుందా? లాస్లెస్ ట్రాన్స్మిషన్ లైన్ ఎక్కడ వచ్చింది?
R and G రిమూవ్ అవుతుంది.
R and G ప్లేస్ లో XL
Very good. Very good. So here R will be neglected and here G will be neglected because at high frequencies the reactance of inductance is more than R and here capacitance is more than G, right? So it will be considered in low frequencies. At high frequencies R and G will be neglected. Then what is the equation Z0? What is the equation?
Under root J omega L by J omega C.
Under root J omega L by J omega
C.
C. So here J omega get cancelled. What is the final
under
equation?
root L by C.
Square root of L. Very good. So it is a characteristic impedance at high frequencies. So it is at low frequencies and it is at high frequencies. Okay?
Okay, ma'am.
What is the next one?
Propagation constant.
Propagation constant. So what is propagation constant? Here, in the transmission line, we are consider the voltages and currents, right? Yes, in the transmission line, we have voltages and currents. These may be entered or leaving. Entered or leaving, right? Yes or no? The transmission line, we have two parameters mainly, voltages and currents. So the voltage and current may be entered or can be leave from the circuit, right? Enter into the circuit or leave from the circuit. Yes? If it is a transmission line, we have voltage source. And at the output terminals, we can take the voltage also. Right? We are consider the voltages V1, V2. We are measured here and here voltages. And currents, here I1 and here I2. We are considered for 1 unit length, ma. Okay? 1 unit length. Okay? So then what is the propagation constant? That means, so it will determine the in which way the voltages and currents will vary in the transmission line. Okay? మనకి ట్రాన్స్మిషన్ లైన్ లో కరెంట్స్ ఎలా వేరీ అవుతున్నాయి, వోల్టేజెస్ ఎలా వేరీ అవుతున్నాయి. సో దట్ విల్ బి డిటర్మైన్డ్ బై ద ప్రొపగేషన్ కాన్స్టాంట్. ఓకే, సో దాన్ని మనం ఎలా చెప్తాము, ఎలా వేరీ అవుతున్నాయండి? అకార్డింగ్ టు log E I1 by I2. This is for current, and for voltage log E V1 by V2. ఓకేనా? మనకి ట్రాన్స్మిషన్ లైన్ లో వోల్టేజెస్ అండ్ కరెంట్స్ ఎలా వేరీ అవుతున్నాయి, in which way the voltages and currents will be varying in the transmission line, that will be determined by the propagation constant. Okay, and then what is propagation constant? That means here, so it is a natural logarithm of the ratio of the current or voltages which are entering into the circuit or leaving from the circuit. That is the definition of propagation constant. Okay na? ఏమో మేడం, ఏం అర్థమవుతుందో ఏమో, అంతేనా? అరే రెస్పాండ్ అవ్వండి.
ఓకే మేడం, ఓకే.
లేదంటే చెప్పుకుంటూ వెళ్ళాలా నా ఫ్లోలో నేను. అర్థమైందా ప్రొపగేషన్ కాన్స్టాంట్?
అర్థమైంది.
ఫస్ట్ ఎందుకు యూజ్ చేస్తున్నారు ప్రొపగేషన్ కాన్స్టాంట్ ని?
డిటర్మైన్
వేరియేషన్స్ ఇన్ ద వోల్టేజెస్ అండ్ కరెంట్స్. ఎక్కడ? ట్రాన్స్మిషన్ లైన్ లో. Because we are dealing with transmission lines only, right? Okay, then what is propagation constant? Logarithm of the natural logarithm of the ratio of currents or voltages which are entering or leaving from the circuit. That is propagation constant. Okay, so it will be represented with P. Okay, na? And P can also be written in terms of Z and Y. Square root of product of Z, Y. It can be represented in terms of Z and Y also. So what is Z?
Impedance.
Series impedance. And Y means?
Admittance.
Parallel.
So parallel admittance means shunt admittance. Okay, na? Series impedance, shunt admittance. Okay, this is about propagation constant. So this one clear? If you clear with this one, I will go to third one. Attenuation and phase constant. Shall I go? Attenuation and phase constant. So attenuation means distortion. Distortion, or we can say losses also. And phase, angle of the signal, right? So here attenuation constant and phase constant. So in the propagation constant, we are taking the P equals to Zy, right? P equals to under root Z and Y. So it can be written also R plus J omega L into G plus J omega C. That means Z equals to R plus J omega L, Y equals to G plus J omega C. Okay, so దీన్ని మనం సింపుల్ గా ఏమని రాసుకోవచ్చు అంటే P equals to alpha plus J beta. Okay, so propagation constant ని మనం ఇలా కూడా రాసుకోవచ్చు, alpha plus J beta. So in this, alpha will represent the attenuation constant and beta will represent the
Phase constant.
గర్ల్స్ ఎవరు లేరా అమ్మ ఆన్లైన్ లో? అందరు మ్యూట్ పెట్టుకొని కూర్చున్నారా మరి?